Bismillahirrahmanirrahim. Starting with the name of Almighty Allah. Today we are going to cover how we solve the recurrence equations. In the previous lectures on merge sort and quick sort, we watched how a recurrence equation is generated from the recursive function. If you can recall this lecture in which we studied the merge sort, a recursive function of the merge sort. Here we can see there are two recursive calls to the subproblems of size left half and the right half. There were two other costs, that is the cost of division, that is here, and the cost of merging the arrays, that is conquering, the cost of conquering. So we saw here that this is because the size is half, so there are two recursive calls of half sizes that were summed up into 2t of n by 2, and theta of 1 plus theta of n was converted into theta 1. So we got this recursive recurrence equation, that is t of n is equal to 2t of n by 2 plus theta of n. So this was the recurrence equation of merge sort. In today's lecture, we are basically covering how the time complexity or the running time of an algorithm, of a recursive algorithm, is calculated using the recurrence equation. Because when we go for the time complexity for any recursive function, first of all, the algorithm is converted into recurrence equation, and then we solve it for its time complexity. Okay, the previous lectures of merge sort and quick sort also explained how we convert a recurrence, how we can convert a algorithm or the time complexity intermediate step of algorithm to time complexity, that is the recursification, how we can convert a algorithm into a recursive equation. And then in this current lecture we are going to see how the recurrence equation is converted into the time complexity. These are the few examples of recurrence equations and their time complexities. Definitely there are some steps required to convert a recurrence equation into its time complexity. So that's what we are going to do today. For example, in this one, t of n is equal to t of n minus 1 plus n. So it shows, because there is no coefficient of this term, so that means there would be only one subproblem of always size reduced by 1, and this n would be the cost of divide and conquer. So in the second equation you can say there is only one subproblem of, and the subproblem is always halving the size of the original problem, and there is only a constant time complexity for time for divide and conquer. In the third equation you can see that it is again dividing the subproblem into half of its size. There is only one problem, and the time complexity of divide and conquer is n. And the third one is, you can say there are two subproblems of size half, and the cost of divide and conquer is only 1. After the calculation we can find its complexity, that would be theta of n. Now, so basically there are four methods to solve this recurrence equation. Number one is iteration method, number two is substitution method, number three is recursion tree method. So recursion tree method, if you can recall previous two lectures on merge sort and quick sort, it was solved using the recursion tree method. And there is a direct method of that is called master theorem, in which you just calculate the few variables and then give a direct answer of time complexity. Starting with the first method, that is iteration method. The name specifies iteration, so that means you are going iteration by iteration, and then you calculate a summation, and after that one you convert that summation into its notation. So basically we convert the recurrence into a summation and bound it using the non-series. How we do it, we iterate the recurrence until the initial condition is reached, and then using the back substitution to express the recurrence in terms of n and its initial condition. Let's start with an example so then you can understand what the theory means. So let's have an example first, and then you will be able to understand this theory in a better way. Let's have an equation that is t of n is equal to t of n by 2 plus c. What we need to do is, let's say this one is our rough side. Here we need to find out the t of n, that is time complexity for n numbers. We have to find first the time complexity for the half of the numbers. So we just write down the original equation, that is t of n by 2 plus c, because here we need t of n by 2. So we convert every n into n by 2. So it will become t of n by 2 plus t of, convert this n into n by 2, so that is n by 2 by 2 plus c. So it means t of n by 2 is equal to t of n by 4 plus c. Now putting this value of t of n by 2 into this equation, so we get t of n is equal to t of, so here I'm just marking the bracket so that you can understand that what is the replacement of this part only. So t of n by 2 is this, t of n by 2 is converted into t of n by 4, t of n by 4 plus c. So this is being replaced by for this function, and this is the plus c, that is after this one. So just simplifying this one, t of n is equal to t of n by 4 plus c plus c. Here we need, now to solve this one, we need t of n by 4. Doing the same thing, writing the original equation, that is t of n is equal to t of n by 2 plus c. So, and putting the value, replacing n with n by 4. So t of n by 4 plus t of n by 4 by 2 plus c. So it will become t of n by 4 is equal to t of n by 8 plus c. Now replacing this value of t of n by 4, that is t of n by 8 plus c, in place of this one, so in place of this expression. So we get t of n is equal to t of n by 8 plus c, and then there are two c's outside this one, so plus c and plus c. Just to keep the scenario simple, we assume that our n is in the form of 2 raised to power k. So doing this replacements, and we are going through these iterations one by one, finally at some point we will reach at t of 1 plus c at some point, doing all the steps down here, and then we will be having some c's here. So we don't know how many c's are there, but we will be having some c's here, and finally after replacing t of 1, we will be getting all the c's here. So this is the series that we have achieved. So if we were knowing how many c's are there, so it would be it might have been very easy for us to find out this one, but here we are not able to know. So but we have assumed one thing, that n is equal to 2 raised to the power k. So if we know the k, so taking the log of both sides, it will become log of n is equal to log of 2 raised to the power k. So it will become log of n is equal to log of 2k, and that is equal to k because log of 1 is 1. Okay guys, so it shows that there are total kc's, and here we can see that the k is log of n. So it means the time complexity for this one is c times log of n, so which can be expressed as theta of log of n. So this is how we can calculate our time complexity of any recurrence equation using the iteration method. Okay, taking another example in a bit faster way, t of n is equal to 2t of n by 2 plus n. So there are two sub problems. Every problem is of size half of the original one. So this is the cost of divide and conquer. We need the value of t of n by 2, but it is not known, so we will calculate it in just like the previous one. So writing the original equation, that is 2t of n by 2 plus n. So replacing n with n by 2, t of n by 2 is equal to 2t of n by 2 by 2 plus n is replaced by n by 2. So it will become t of n by 2 is equal to 2t of n by 4 plus n by 2. And now we are going to replace this one with this t of n by 2. But be careful about while doing this one. So look at me how I am doing it. Please do follow this one. So keep this two separate from the inner part and replace this inner part with this equation of the left hand side. That will become 2t of n by 4 plus n by 2. So this is what you have replaced. Now the remaining part of this equation is plus n. Okay, so just simplifying a little bit, it will become multiplying 2 inside, so it will become 4t of n by 4 plus n. This 2 is crossed with this one, and then this is outside this one, so this is n. Now doing the same process again, t of n is equal to 2t of n by 2 plus n, replacing n with n by 4, so it will become t of n by 4 is equal to 2t of n by 2 by 2 plus n by 2. So it will become t of n by 4 is equal to 2t of n by 4 plus, so n is being replaced by 4, so n by 4, so it is also replaced by 4, so now it is okay, so it will become 8. So now replacing t of n by 4 from here into this one, So it will become 4. Just keep this 4 away from the what you are replacing or on which you are iterating. So this will become 2t of n by 8 plus n by 4 plus n, and then again the second n. Just simplifying a little bit, so 4 into 2 is 8 t of n by 8 plus this 4 is crossed with this one, is cancelled, so it is n plus 2 n's, this one plus n. Again for the simplification, assuming our n is in the form of 2 raised to the power k. Now here if you can see that you can write this 2 as 2 raised to the power 1, you can write this as 2 raised to the power 2, you can write this 8 as 2 raised to the power 3. So there are 3 to the raised power 3 is there is 3, then there are 3 n's. If the power is 2, there are 2 n's. If power is 1, there is 1 n. So at the end, just like in the previous example, so we can say that this one would be 2 raised to the power k when it reaches to t of 1, plus there would be n's. You can write it as t of k plus n plus n plus n so on up to, and we just need to calculate the number of n's. Is that okay? So if we see that there are, if there is 1 n, there's power is 1, there's 2 n's, the power is 2, there are 3 n's, power is 3. So if there are 2 raised, if you can express it in the form of 2 raised power k, so that means there would be k n's. And in the same way, so it means our n is equal to 2 raised to the power k, so the k would be log of n. So just like in the previous example, as we have assumed that n is equal to 2 raised power k, so it will become n plus, so n times log of n, because there are log of n n's. So adding it up, it will become, in the term, you can easily express it as n log of n. The bigger form goes into as a g of n in theta notation. So this was the second example. Hopefully you can understand this one, and if you have any queries, please don't hesitate to ask. Just mention a time in the comment and you can put your question there. I will be answering it.